Welcome everybody, how are you? Today we are going to talk about the lesson 1, the first lesson of geometric, talking about similarity of polygons. Okay, similarity of polygons. Definition: two polygons M1, M2 of the same sides are said to be similar if the following two conditions satisfied together. Number 1, their corresponding angles are congruent. Number 2, the length of their corresponding sides are proportional. Okay, again, the first condition, their corresponding angles are congruent. 2, the length of their corresponding sides are proportional. In this case, we shall write the polygon M1 similar to the polygon M2. That means the polygon M1 is similar to polygon M2. This sign refers to similar to. Look at this figure: A, B, C, D, and X, Y, Z, L. In the opposite figure, if measure of A equal measure of X and measure of B equal measure of Y, measure of C equal measure of Z, measure D equal measure of L, and the proportional between AB over XY equal BC over YZ equal CD over ZL equal DA over LX. So in this condition we have two conditions, number 1, number 2. Then the polygon ABCD is similar to ABCD, the polygon. Look at here, ABCD, the polygon ABCD similar to the polygon XYZL. Remark 1. On writing the similar polygons, it is preferred to write them according to the order of their corresponding vertex to make it easy to discern of corresponding side lengths. For example, if the polygon ABCD similar to the polygon XYZL, then measure of A equal measure of angle B, measure of angle A equal measure of angle of X, measure of angle of B equal measure of angle of Y, measure of angle of C equal measure of angle of Z, measure of angle of D equal measure of angle of L, and proportional AB over XY equal BC over YZ equal CD over ZL equal DA over LX. Remark 2. If the polygon ABCD similar to the polygon XYZL, then AB over XY equal BC over YZ equal CD over ZL equal DA over LX equal K. K is constant, similar ratio or scale factor or similarity, and K more than 0. If the scale factor of similarity. Mark 2. If the polygon ABCD similar to the polygon XYZL, then AB over XY over AB over XY equal BC over YZ equal CD over ZL equal DA over LX equal K. K similarity ratio or scale factor of symmetry, and K more than 0. If the scale factor of symmetry of polygon ABCD to polygon XYZL equal K, then the scale factor of the similarity of polygon XYZL to polygon ABCD equal 1 over K. We will inverse the constant. Remark 3. Let K be the similarity ratio of the polygon M1 and M2. If K more than 1, then the polygon M1 is an enlargement of polygon M2, where K is called the enlargement ratio. Again, remark 3, let K be the similarity ratio of polygon M1 to polygon M2. If K more than 1, then polygon M1 is enlargement of polygon M2, where k is called enlargement ratio. If k more than 0 less than 1, then polygon M1 is shrinking of the polygon M2. Shrinking, okay, shrinking to polygon M2, where k is called shrinking ratio or minimization. Okay, we have shrinking or minimization. If k equal 1, then polygon M1 is congruent to polygon M2. In general, you can use the similarity ratio in calculation of the dimension of similar figures. Okay, you can use the similarity ratio in calculation of the dimension of similar figure. Remark 4. In order that two polygons are similar, the two conditions should be verified together, and verifying one of them only is not enough to be similar. For example, our rectangles are not similar because although their corresponding angles are equal in measure, each equal 90 degrees, but the length of their corresponding sides may be not proportional. Also, all rhombus are not similar because although length of their corresponding sides are proportional, but their corresponding angles may be different in measure. It's very important, okay, about rectangle and rhombus. Again, all rectangles are not similar because although their corresponding angles are equal in measure, each equal 90 degrees, but the length of their corresponding sides may be not proportional. Also, all rhombus are not similar because although length of their corresponding sides are proportional, but their corresponding angles may be different in measure. Remark 5. The congruent polygons are similar, but it isn't necessary that similar polygons are congruent. Again, remark 5, the congruent polygons are similar, but it is not necessary that similar polygons are congruent. Remark 6, if each two polygons is similar to a third polygon, then they are similar. Again, if each of two polygons is similar to the third or to a third polygon, then they are similar. Such that if polygon M1 similar to polygon M3, polygon M2 similar to polygon M3, then polygon M1 similar to polygon M2. Remark 7. All regular polygons of the same numbers of sides are similar, such that square, hexagon, for example, all equilateral triangle are similar. All square are similar. Example number 1. And this solution. Okay, we will solve another example. Look with me. Look at these properties. The ratio between the perimeters of two similar polygons equal the ratio between the length of two corresponding sides of them. Okay, we can solve by this property. Okay, look with me here. Exercise 1, similarity of polygons. Look at question number 1. Show in which of the following pairs of polygons are similar. Write the similar polygons in the order of their corresponding vertex and determine similarity ratio. Question number 1. Polygon X, Y, Z, L and polygon A, B, C, D. We have the ratio between LX and look at Z, the angle of Z equal the angle of D, right D here, and angle of Y equal C, angle X equal angle of D or P, sorry, P, ZYXL and L corresponding angles equal A. Alright, the proportional. The first ratio ZY over DC, and yx over cb, and we will solve, or we will complete the ratio. Look at here, xl over BA, LZ over AD, and then we can find the ratio between corresponding sides. ZY equal 6.8 and DC equal, look at here again, ZY equal 6.8 and DC, the length of DC equal 8.5. We can find the ratio, divided, we can cancel point by multiply by 10, 68 over 85. We can find the ratio 85 and 68. Okay, YZ, YX equal 9.6 and CB 12 centimeter, XL equal 8 centimeter over PA equal 10, and LZ 7.2 over AD equal 9 centimeter, can divide it by 17, 68 divided by 17 equal 4, 85 divided by 17 equal 5. We can cancel point, 96 over 120. We can divide it by these even numbers, 96 divided by 4, 9 divided by 4 equal 2, and the remainder 1, 16 divided by 4 equal 4, 120 divided by 4 equal 30, can divide it by 6, result will be 5, 24 divided by 6 equal 4, so we have the proportional 4 over 5 and 4 over 5. We can complete here, divided by 2 equal 4 over 5. We can cancel point by multiply 10, 72 over 90, can divide it by 9, will be 10, 90 divided by 9 equal 10, 72 divided by 9 equal 8, and we can sum this by divided by 2 equal 4 over 5. You can use a calculator to find the result. So we have the similarity between the first polygon and second polygon, because corresponding angles are equal in measure of angle of Z equal measure of angle of D, and measure of angle of Y equal measure of angle of C, and the measure of angle of X equal measure of angle of B, measure of angle of L equal measure of angle of A. So if you want to solve in examples, you must do these steps. It's easy for you. You can write two polygons by corresponding angles. I write about this thinking. You must thinking about angles. So look at again in this example, you must look at this sign. This sign refers to the angle X, the measure of angle of X equal measure of angle of B, and this sign or this point here, measure of angle of C equal measure of angle of Y, measure of angle of D equal measure of angle of Z. Okay, so we can write the similarity between ZY XL and the polygon DCPA. Second question. Look here. We have two squares. Look at angle C and angle B, the square. Each angles are equal in measure, and the measure of each of them equal 90 degrees. So the first square is similar to the second square. It's easy for you. Okay. Question number 3. Look at question number 3. We have two rectangles, first and second. The first rectangle XYZL and ABCD. We have two dimensions AB and BC in the first, and XY and YZ. You must find the ratio between two dimensions. Okay, to find the result between AB, we will write here ZY CB equal 12, ZY equal 6 equal 2, but this ratio not equal the another ratio. We haven't proportional here, so we haven't the similarity. So XYZL not similarity to ABCD. It's okay for you? Okay, question number 4. We have parallelogram. Two parallelogram. We have ABCD, JFEX. Two parallelogram. Look at angles. A equal angle G. Why? Because we have the measure of angle of F equal 110, and the measure of angle of G will be 70 degrees. So the corresponding angles are equal in measure, but you must find the proportional between corresponding sides. Like that, AB over GF. You must find the ratio between EB and GF, and CB over EF. AB equal what? AB equal 21, because in parallelogram each of the sides are equal in length. AB equal DC, so AB equal 12 centimeter, or 21. AB equal 21, and GF equal XE equal 28 centimeter. You can find by divided by 7. It's simplest. 21 divided by 7 equals 3, 28 divided by 7 equal 4. CB equal 12, and EF equal 16. You can find the ratio by divided by 2 or 4. You can divide it by 4. 12 divided by 4 equal 3. 16 divided by 4 equal 4. So we have the proportional here. It's easy for you. So ABCD, the parallelogram ABCD, similar to GF AX. Okay, because corresponding sides are proportional and corresponding angles are equal in measure. So we have the ratio between AB and GF, and CBA and EF equal 3 over 4, 2 dimensions. It's easy for you. You must do these steps. It's the first and the second. Measure of A equal measure of G, measure of B equal measure of F, measure of C equal measure of E, measure of D equal measure of X. Because in parallelogram ABCD, each opposite angles are equal in measure. يعني measure of angle of A equal measure of angle of C, and the measure of angle of B equal 110. because measure of angle of A plus measure of angle of B equal 180. It's properties of parallelogram. Okay, another question. Look here, question number 5. We have two rectangles. If we have two rectangles, we must find the ratio between two dimensions. The first, LX LX and A, and XY and AB. Two dimensions, lengths and widths. Okay, you will find here two dimensions. Question number 5. AB over LZ, AB over LZ, AB equal 20 over LZ, LZ equal 30. The result will be 2 over 3 in simplest form. ZY the second, okay, but the first CB, we write CB here over ZY. CB, the length of CB, okay, CB over ZY, CB over ZY, CB equal 28 centimeter. ZY equal 49. We can divide it by 7. 28 divided by 7 equal 4. 49 divided by 7 equal 7. Oh, it's not equal to. We haven't the proportional here. So two rectangles not similarity. Okay, because the ratio AB over LZ not equal to CB over ZY. Okay, it's easy for you. So you must find the ratio between two dimensions, two corresponding dimensions. We have question number 6, two rhombus. The first rhombus ABCD, look at here with me, and again ABCD and YXLZ. Look at the measure of A will be 110 because measure of angle of B equals 70, and the sum of measure of A and measure of B equal 180. So the measure of angle of A equal 110. So each corresponding angles are equal in measure. Then you must find the ratio between each two sides. Each two sides, the ratio will be constant. So we have each corresponding angles are equal in measure, and each sides are equal. Each corresponding sides are equal in proportional. Okay, proportional are equal. So if you have two rhombus, you must find the angles because the ratio between each two corresponding sides will be constant. So question number 6, we have ABCD rhombus similar to YXLZ. It's easy for you. It's easy because again measure of angle of A equal measure of angle of Y, measure of angle of B equal measure of angle of X, and the ratio between each corresponding angles are equal in measure and equal, and each corresponding sides are equal in lengths. Okay, such as that 7 over 10, it will be 0.7. We have constant, or if you write 10 over 7 over 10 over 7, we will have the constant between each two sides. Okay, another question. Look at question number 7. We have two triangle. Question number 7, ABC and another triangle APC. Look at the measure of angle of B equal measure of angle of D, and measure of angle of A equal measure of angle of E. We write E here. Measure of angle of B equal measure of angle of D. Measure of angle of C equal measure of angle of F. So we must find the ratio between AB and ED. EP over ED, BC over DF, and CA over FE. Okay, we can find the ratio between AB equal 4.9, ED equal 8.4. We can cancel point by multiply by 10, numerator and denominator. 49 divided 84, we can divide it by 7. 84 divided by 7 equal 12. The ratio will be 7 over 12. And BC over DF, BC equal 2.8 over DF, length of DF equal 4.8. We can divide it by 7 or cancel point here. 28 divided by 4 equals 7. When divided by 4 equal 12. CA over FE, CA over 4, CA equal 4.2, FE equal 7.2. We can divide it by 6, 12, and this divided by 12 equals 7 because we multiply by 10 to cancel the point, numerator and denominator. So we have the proportional between each two corresponding sides. So two triangles are similarity. You can find the similarity between two of them by first condition or second condition only. Okay, it's a property of two triangles. Another question. Question number 8. We have two trapezium. Look at with me. We have measure of angle of X equal measure of angle of C, measure of angle of L equal measure of angle of B, and measure of angle of Y equal measure of angle of what? He don't give me, but you know measure of angle of L and measure of angle of Z, the sum of them equal 180. It's okay. Measure of angle of X plus measure of angle of Y equal 180. And we have two parallel. Look at here. ZY parallel to LX, DA parallel to CB. So we can write here the first trapezium DA BC, and the second trapezium, the measure of D, I don't know, DE and ZY. We can write the second by the angles. Measure of angles of P equal measure of angle of L. Measure of angle of C equal measure of angle of X. LX and ZY. Look at again DABC, DABC. We can write here YZLX, YZLX. It's okay for you? Okay, again, look at here DAPC and YZLX. Okay, we can find the ratio between DA and YZ, and AB over ZL, BC over LX, and CD over XY. We can find the ratio between each corresponding length. DA equal 7, YZ 5.6, multiply by 10, numerator and denominator, the result will be 70 over 56. We can divide it by 7 equal 8. 10 can divide it by 2 equal 5 over 4. AB over ZL, AB equal 18. 110 divided by 2 equal 55. Okay. 20 can divide it by 9 equal 10. Divided by 9 equal 8. Can simplest divided by 2 equals 5 over 4. Okay. The last ratio, CD over XY, CD 13, XY equal 10.4. We can multiply by 10, divided by 2 equals 65, divided by 2, 54. We can divide it by 52. We can divide it by what? 52. 65 divided by 13. Okay, divided by 13 equal 4, divided by 13 equal 5. The result will be 5 over 4. Okay, the two trapezium are similarity. We can write the first DABC similar to YZLX. It's okay for you because each angles are equal in measure, and we have properties. We have proportional between the corresponding sides. So trapezium DABC similar to YZLX, we have similar between two polygons because each angles are equal in measure. We have similarity between DABC and YZLX between. So we have similarity between DABC and YZLX because each corresponding angles are equal in measure and each corresponding sides are proportional. Question number 2. In the opposite figure, triangle ABC similar to triangle NMLL, the lengths of sides are shown on the figure. Okay. Find the scale factor of similarity of triangle ABC to triangle NML. Okay, we can find the scale factor between two triangles by finding the ratio between each corresponding sides, such that we can write AB over NM. It will be K. K is constant, refers to the scale factor of symmetry of triangle ABC and triangle NML. We can write AB equal 15 and NM equal 10. We can divide it by 5. 15 divided by 5 equals 3. 10 divided by 5 equal 2. So the scale factor of symmetry of triangle ABC and triangle NML equals 3 over 2. Okay, this is number 1. About question number 2. Question number 2. Find the values of x and y. We can find the ratio between corresponding sides. 14 divided by y equal 12 divided by x. Okay, 12 divided by x. 15 divided by 10. It will be 3 over 2. We can find y by find the values of it. About 14 multiplied 2 divided by 3, and x we can cancel it. It's proportional, and find 2 multiplied 12 divided by 3. It's okay. So we can find x equal, disappear this, and 2 multiplied 12 divided by 3. 2 multiplied 12 divided by 3. 12 divided by 3 equal 4. 4 times 2 equal 8. Y equal 14 times 2 divided by 3. We can find the result. 2 times 4 equal 28 over 3. We can find the whole numbers here. 3 times 9 equal 27 and the remainder 1. It's okay, centimeter and this centimeter. It will ask question number 2. Question number 3. Look at with me here. Question 3. In the opposite figure, polygon ABC similar to EFGH. Find the scale factor of symmetry of polygon ABCD to polygon EFGH. Okay, question number 3, we can find the values of x and y and find the scale factor. Scale factor, we will refer it by K equal EB over EF, because we have symmetry between two polygons. AB over EF. AB of equal y plus 2. Oh, it's unknown here. Okay, never mind. We can write here and EF equals 6. We can find the ratio or find the result. Okay, we will choose another ratio because we have symmetry, such that DA and HE. DA and HE, okay? DA over HE to find the scale factor. DA equal 12 centimeter, HE equal 8 centimeter. We can find the ratio by simply divided by 4. 12 divided by 4 equal 3. 8 divided by 4 equal 2. The ratio will be 3 over 2. Question number 2. We can find the value of x of y by find the proportional between first over second, such that, look at here, we have two polygon A, B, C, D similar to polygon E, F, G, H. We can write A, B, C, A, B, B, C, B, C, okay, A, B, B, C, C, D, D, A. You can write this method, okay, E, F, F, G, G, H, H, E. And then in this proportional you can put the value of each of one, such that AB equal y plus 2, EF 6, PC, the length of PC we haven't. The length of EF or FE equal this FG, okay? Again, this FG we haven't. Never mind. We'll write here. And CD 15 and GH X. And what about DA? DA, length of DA equal 12. HE equal 8. So we can find X by multiply about means divided 12. 8 divided or 8 multiply 15 over 12. 8 multiply 15 equal 120 divided by 12 equal 10. So X will be 10 centimeter. X equal be 10 centimeter. And what about Y? We can find the ratio 12 over 8 and Y plus 2 over 6. You can write Y plus 2 equal 6 multiplied 12 divided by 8. 6 multiplied by 12 divided by 8. 6 times 12 equals 72 divided by 8 equal 6 multiplied 12 equal 72. Okay, 72 divided by 8 equal 9. So y plus 2 equal 9. Then y equal 7 centimeter. Okay, it's easy for you. Okay, question number 4. We have triangle CBA similar to triangle CED. Using the length shown on the figure to find the length of ED and EA. Okay, we can find the length by write the ratio. Look here with me. Question number 4. Triangle CBA similar to triangle CED. So we can find the proportional between the first ratio CB BA AC, CB BA AC, okay, CE ED DC, and then we can find the unknown by put the length in the figure. CB equal, look at here, CB 5 plus 7 equal 12, CE equal 4, BA CBA again, CBA, okay, BA here 9. You must try it after or write with me to solve the examples. Pay attention with me, okay? Pay attention. Okay, again, BA equal 9, ED we don't know, ED, AC, length of AC we don't know, the length of AE, okay, we will write AC here, and DC, length of DC equal 5. We can find the length of ED first. ED equal 9 multiply 4 divided by 12. 4 times 9 equals 36 divided by 12 equals 3. So ED equals 3 centimeter. Then we can find AC by 12 divided by 4 equals 3. 3 times 5 equals 15. Okay, AC equals 15 centimeter and ED equals 3 centimeters. So he wants to find the length of EA. Look here, we know EA plus EC equal CA. You know that? CA again, sorry, CA equal AE plus EA. Look at here with this hand, AC plus EA equal CA. So we can find the length of EA by find the difference between 15 and 4. 15 minus 4 equal 11. So the length of AE equal 11 centimeter. AE equal 11 centimeter. It's easy for you. Okay, question number 5. In the opposite figure, triangle ETE similar to triangle ABC. Prove that DE parallel BC. D A parallel BC. Okay, we can find the parallel to find each angles. Interior angles are equal in measure. Alternate angles are equal in measure, sorry. Alternate angle or corresponding angles are equal in measure, or find the sum about two interior angles equal 180, and so on. This is properties about parallel. So look at here, if we write the ratio between ADE, triangle AD, and triangle ABC, we can find the angles, the interior angles or corresponding angles or alternate angles. It's easy for you. Look at with me here. Measure of angle of D will be measure of angle of B, because triangle ADE similar to triangle ABC, then each angles in the first are equal the corresponding angles in the second. You understand? Okay, I will write here to understood. Question number 5. Look at with me here. Therefore, triangle ADE similar to triangle ABC, then we can find the measure of angle of A. It's the measure of angle of A here. We have common angle, vertical common here. So we can find the measure of angle of D equal the corresponding angles P, measure of angle of B. So measure of angle of D equal measure of angle of A of B. It's easy for you. So AD parallel to CB, because measure of angle of D equal measure of angle of B, or you can say measure of angle of E equal measure of angle of C, because we have corresponding angles. Okay, we have it here, alternate angles. We have corresponding angles. So AD parallel to CB, because measure of angle of D equal measure of angle of B. It's easy for you about each side of the first triangle congruent of its corresponding from the other triangle. The two triangles will be congruent, but in this figure we have symmetry between AED and ACB. Okay, straight line intersect two parallel straight line, then each two corresponding angles are equal in measure. Okay, it's properties about the intersection, about two parallel straight line or line segment. Again, AD parallel CB, because AB intersection DE and BC. DP because measure of angle of D equal measure of angle of B, and the length EP intersection AD and CB, and we have corresponding angles. This angle D and angle B are equal because we have symmetry between two triangles ADE and ABC. Okay, we can complete it to find the length of BD and CE. Like here, look at here, look at this steps. I will write AD, DE, EA over AB and BC, CA. We can write here the length of AD 6, AB 6 plus DB اللي هي كلها AP here, DE D E equal 4, BC equal 12, CA, right, CA here, and EA, length of EA equal 5. So we can find the length about AB. AB equal AB 6 multiply 12 divided by 4. 12 divided by 4 equals 3, so times 6 equal 18 centimeter. And CA 5 times 12 divided by 4. 12 divided by 4 equals 3. 3 times 5 equal 15. We can find the length of BD. Look here with me. BD, we can find the length about subtract between 6 and the length of EB. Length of EB equal 18. 18 subtract 6 equal 12. So BD equal 12 centimeter. And we can find the length of CE here. CE equal the length of EC equal 15. 15 minus 5 equal 10. 15 minus 5 equal 10 centimeter. It's easy for you. Okay, question number 6. In the opposite figure, triangle ABC similar to triangle DEF, and DE equal 8 centimeter, EF equal 9 centimeter, FD equal 10 centimeter. If the perimeter of triangle ABC equal 81, find the side length of triangle ABC. Okay, look here, I will solve it here. Okay, question number 6. First, we can find the ratio between corresponding sides. ABC similar to triangle DEF. So we can write the ratio between AP, PC, CA, DE, EF, FD, and then we can find the perimeter of triangle ABC equal 81. Perimeter of triangle ABC equal 81. This is the perimeter. Okay, this is a perimeter. And the perimeter of triangle ABC, we will write here x unknown. It refers to perimeter of triangle ABC. Okay, then we can find the ratio, and then write 81 over x. X refers to perimeter of triangle of another triangle. Look at here, EFD. Okay, we can find the perimeter of triangle EFD by find the summation between all lengths here. 10 plus 9 plus 10 plus 9 plus 8, 9 plus 8 equals 17 plus 10 equal 27. So x we will cancel it and try 27 here. Okay, again x refers to perimeter of triangle EFD. Triangle EFD, the perimeter of this triangle equal 9 plus 10 plus 8 equal 27, and we have length AB. we don't know, BC we don't know, CA we don't know, DE equal 8 centimeter, EF 9, FD equal 10. It's okay. So we have 81 over 7. I will write another paper. Look with me here. We can find AP. 81 divided by 27 equals 3 over 1. So 3 multiplied by 8 equal 24 centimeter, and PC equal 3 times 7 equal 20, 3 times 9 equal 27, and CA 3 times 10 equals 30 centimeter. Okay, you must know this method. Again, if the teacher give you in the example a perimeter of one of two triangle, you must find the ratio between all each corresponding sides, proportional 1, proportional 2, proportional 3, and then we can find the perimeter here about AB plus BC plus CA over perimeter of triangle DEF, DE plus EF plus FD equal x equal will be 27, because 9 plus 8 plus 10 equal 27. So 81 divided by 7 equals 3. 3 multiply 8 equal 24. AB equal 24 centimeter. BC equal 27. CA equals 30 centimeter. Question number 5. If K1 is the scale factor of symmetry of polygon M1 to polygon M2. Right here with me to know these properties. Question number 5. Pay attention with me. K1 is symmetry of M1 and polygon M1 and M2, and K2 is the scale factor of symmetry polygon M2 and M3. This is the scale factor of symmetry of polygon M1 to M3. We want to find M1 over M3. If we multiply them, K1, we want to find M1 over M3. If you find the result about K1 multiply K2, we will have M1 over M2 multiply M2 over M3. Again, you look at with me here, it's appear now. Okay, the result will be M1 over M3. So he want to find the ratio between M1 and M3. M1 over M3 equal K1 multiply K2. Again, he want to find M1 to M3, so we will multiply K1 to K2. K1 multiply K2, the result will be M1 over M3, because we cancelled M2 by M2. M2 over M2 equal 1. M1 multiply 1 equal M1. M3 multiply 1 equal M3. The result will be M1 over M3. So the result will be K1 multiply K2. So we will choose letter P about question number 5. Okay. Question number 6. In the opposite figure, rectangle ABCD similar to rectangle XBYL, then the length of YZ equals space centimeter. Okay, I will solve it here. Look here. Question number 6. ABCD similar to XBYL. So we can write AB over XB equal BC equal PY CD equal YL equal DA over LX. AB equal 12, XB 2, BC equal 12, because AB again AB equals 6, again AB equals 6, XB equal 2, BC equal 12, because each opposite sides are equal in length, 12 centimeter. PY we don't know PY. You want to find 1c. Okay, we will find by here. Multiply 12 and 2. 12 multiply 2 divided by 6. 24 divided by 6 equal 4 centimeters. So by equal 4 centimeter. This 4 centimeter. He wants to find the length of cy. We will find by subtract 12 because CB 12 centimeter and YB equal 4. 12 minus 4 equal 8. So CY equal 8 centimeter. By subtract. It's easy for you. This rectangle here, I will draw here. We have this length YP equal 4 centimeter. This 4 centimeter, and all these sides CB equal 12 centimeters. So the result about CY equal 8 centimeter. Question number 7. In the opposite figure, if triangle ABC similar to AED, measure of B equals 3x plus 10, measure of AED equal x plus 10. Look at here. Measure of P equal measure of AED because we have two similarity between two triangles. So the measure of angle of E equal measure of angle of B. So we can write 3x plus 10 equal 3x plus 10 equal x plus 30. We can moving x by left hand side. The result will be 2x equal 30 minus 10 equal 20. So the result will be x will be 20 divided by 2 equal 10. He want to find the measure of A. Okay, this triangle here, right angle triangle. We know measure of B equal measure of angle of B equals 3x plus 10. You find the measure of angle of P equal 3 times 10 equal 30 plus 10 equal 40. It will be 40 because we know x equal 10. B, C, A. So he want to find measure of angle of A. Measure of angle of A equal 50 degree because 50 plus 40 equal 90. Okay, complementary angles. E plus B equal 90 degree. So the measure will be 50 degree. We will choose letter A. Question number 8. In the opposite figure, triangle ABC similar to triangle DEF, then the length of FE equals B centimeter. You want to find the length about FE. Who can solve it? You must know the sum of interior angles of any triangle equal 180. It's x and 3x 2x. X plus 2x plus 3x equal 180. X plus 2x, 3x plus 3x, 6x equal 180. You can divide it by 6. X will be 30 degree. Okay, so this triangle will be right angle triangle. 30 60 because 30 times 30 times 3 equal 90 degree. This 90 degree, this 30 and this 60. Okay, we know the opposite lengths of this measure will have two hypotenuse A, B, C. The length of CB equal 18 centimeter. So the length of AP equal half of 18 equal 90 centimeter. And another rectangle, another triangle, FDE, it's 3 centimeter, and he want to find this length. Look at here, it's 30 degrees, this will be 30 degree, and this 60 degree because each corresponding angles are equal in measure. So this right angle triangle right angle triangle. Look at here, I will draw it again to be clearly, okay? 3 centimeter and this 30, so this length will be 6 centimeter because it's hypotenuse of this triangle. The opposite length of 30 degree half of hypotenuse, so the length of hypotenuse FE equals 6 centimeter. Okay, question number 9. The opposite figure shows 3 regular hexagons. The ratio between their side lengths is as follows: A to B. Look at about this question. Question number 9. I will solve it here. Okay. Question number 9. A to B to C. It's a ratio between A and B and C. Okay. It's clear. Okay. A B 1, 2, and B to C 3 to 8. So we can circle about grade 6. You remember it? 1 multiplied 3 equals 3, 2 times 3 equals 6, 2 times 8 equals 16, and the side length of greatest hexagon equals 32. It will be 32. So 2 times 16 equals 32, 2 times 6 equals 12, 2 times 3 equals 6. So the perimeter of the smallest hexagon, the length of this equals 6 centimeter. Okay, it's the smallest hexagon, so the perimeter of the smallest hexagon will be 6 multiplied 6. Again, we find the length of the smallest. The length of the smallest hexagon equals 6 centimeter. So the perimeter of the smallest hexagon equals 6 multiplied 6 equals 36. So perimeter of B refers to perimeter. Okay, perimeter of the smallest hexagon, equals 6 multiplied 6 equals 36 centimeter. Okay, we will choose letter C. Are you understood about this question? Okay, you must solve. You will complete this in your homework. Okay, and this question you must solve it. Thank you, my students, to listen about this question. You must understood. Okay, and if any examples was different or difficult with you, you must listen to this question again and solve question number 11. It's easy for you. You must solve it by drawing 2 polygon and complete about these properties. Okay, it's easy for you. Thank you, my students. Goodbye.